I would like to introduce Dr. Andrew Minson. Andrew is originally from Australia and after graduation went to Oxford to do his doctorate. He worked for the international engineering consultancy ARUP for 10 years, working on projects around the world before joining the Concrete Center in the UK. He is now Global Cement and Concrete Association Director of Concrete and Sustainable Construction. Andrew is responsible for the GCCA Roadmap Process for carbon neutral concrete by 2050. Andrew joins us today from London, UK. Please welcome Dr. Andrew Minson.
Bill, thank you very much for that warm welcome. I really want to frame what I talk and how we start the conversation around, well, what it is that we're going to build in the future, how we're going to build it, and what are we going to build it from. And hopefully that will tee up on how the cement and concrete industry in North America is responding and planning for this. So what will we be building in the future? Recently, I was in a workshop with people from around the world when we previously could meet face to face. And out of that workshop, they eventually came up with these two halves. For the people, what we build has to be for the people. What we build has to be for the planet. And you can read that list. And I think we could all sit down and have a conversation about what we think this list should be. I think for the planet, zero emissions, we've heard that. Circular, retrofitted is about rebuilding buildings in the new economy, the post-COVID, such that they can last a long time and be retrofitted. And there's an awareness that we want green spaces within our urban spaces. On the left-hand side for the people, we need buildings and our working places and our leisure and retail places to be healthy, connected, affordable, productive, resilience we've already heard about today. And linking to the being able to be retrofitted, we need them to be adaptive for new needs as our demographic picture changes. So in terms of performance, what do we want our buildings to be able to do? So it won't surprise you that on this list we have resilience almost and up first. Wind, fire, flood. We want them to be energy efficient, end of the glass box. Now we know that construction through the last century and the beginning of this century, people like glass, but it heats up. Will we see the end of the glass box when it comes to architecture and wellness? And a key part of wellness is air quality of our cities. And we need to build in a way, both our buildings and our infrastructure to respond to air quality. In terms of resilience, you can see on the right-hand side an example. That was a cyclone in Australia, but obviously hurricanes in North America cause similar damage. We need to build against those. And the disaster we had 3 years ago, the Grenfell Tower. So this was a concrete frame building, and if it hadn't been concrete frame, it wouldn't have still stood after 24 hours of being completely burnt out. An absolute tragedy, which in a modern economy should not be allowed to happen. And it has had serious ramifications in the UK construction sector, and I think it will be more broadly again. And it's brought fire safety really to the forefront in an area which was probably got complacent. So in the middle of the box, I've got some more here in terms of what we want from building performance, long life, loose fit. I'm a structural engineer, was with Arup for 10 years. The two choices: do you build buildings to last a long time, but be able to be flexible in their use? For example, the building on the right. So long life, loose fit, repurposing of structures is something we're very familiar with, probably in developed countries. This example on the right-hand side is actually from Vietnam, the UN headquarters in Vietnam, which was a housing apartment block and was turned into their offices. An example of a concrete frame building, which because of the resilience, inherent resilience of it, it can be repurposed. The alternative to that would be demountable and reusable. If you've got a temporary stadium for an Olympics for 80,000, 100,000, maybe you want to reduce it down to 40,000. So you make parts of that demountable and reusable. Great awareness currently in terms of the utilization of what we build. Are we using the space in the most appropriate way? Office space is being reevaluated post-COVID. The number of hours that the office is being used, even pre-COVID, was very small, and we need to consider how much we're going to be using those office space in the future and whether multi-purpose is an option. Most of this has been about buildings, but we've also got in our built environment and in our urban ecosystem, we've got the infrastructure. And will new transport change what our urban environment looks like? So much of it is determined by the car. Will that be how we plan our more sustainable built environment in the future? We're going to have new energy sources, and therefore we've got the infrastructure around those new energy sources and wellness again that I've already referred to. So what we build will be changing, and we need to consider what it is that we need as a society. How we build will also change. The first box on here, well, the left-hand side is new. The right-hand side, how we build, also needs to recognize the needs of the planet, those same four things. How we build, productivity is a key thing for the construction sector. It's lagging behind in terms of productivity compared with other parts of the economy. Digitization is now coming in, but has been slow to be introduced into what is typically referred to, and I think it's true for most of the globe. You'll know better in your part of North America. Very fragmented industry that has scope for digitization to improve it and business models to improve the productivity. And part of that, material efficiency. So how are we going to build? 3D printing, it's just an example project on the left. No one's going to live in that, but 3D printing is coming in. Robots on construction sites here laying concrete bricks, and off-site precast construction in a factory. Well, actually, not quite a factory. There it is, up the building. So this 3-story factory started down here and progressed as the building was built to introduce greater safety in the working, to introduce off-site construction elements, and to improve quality control as well. So a factory on site was a new initiative trialed there. So these are all attempts at addressing some of these issues on the top left on how we build. And here's another example where 3-dimensional modules here in concrete can be fitted out in a factory. The kitchens can be fitted, bathrooms can be fitted, and they can be used to construct tower blocks, like this example happens to be in Singapore. So how we build is going to change, is changing. What are we going to build from? So this report is from a little while ago, now in 2017. Balfour Beatty, a major construction company in Europe, did a report on innovations to 2050. And what their crystal ball, what they saw in their crystal ball is the need for a new material, which will work in harmony with the environment, have a lower carbon footprint, and is more durable, meaning less wastage. That's what we need for 2050, is that new material. And it will address, for the planet, the same issues on the right-hand side. I would suggest that at the bottom, there are 5 examples here, but there are more examples of what we need this material to be able to deliver. So on the left-hand side, we've got a sea defense. So it's coping, a material that can cope with aggressive environments. A material that's robust, the bottom left image, fire resistant. And the images on the right, the first one is to do with acoustics. As we have a growing population globally, people need to live beside each other. Many of us are able to live in houses which are not in high density, but much of the world's population is living in very high density, and acoustic separation from neighbors is very important, as is thermal comfort on the far right-hand side. What will we build from? We build from a material that can address a lot of these performance benefits. A material that needs to fit into the project life cycle and deliver the needs of those both at the left-hand side who are designing, those who are building, those who are occupying in the first use of a project, the second use, and ideally can be recycled back to the beginning. So actually we live in a circular economy paradigm now. So let's put those things in a circular paradigm. And this new material, we want it to be supporting biodiversity, lowering the carbon footprint, zero waste, and delivering the needs as you go around this cycle. So what do we want as a designer? As a structural engineer, I want a material that's got the properties I need, and it's got the product range. So the product range, concrete can come, materials can come in all sorts of ways, but we want a range of products that we can design with. For the contractor in the construction, these are some of the parameters that might be useful. We've heard about 3D printing. Can this material be used with 3D printing? Is it moldable? Can it be built in a modular way? Can it be used with other materials in a composite way? What is its performance? Can it then be demountable, adaptable, or long life loose fit? Is it fully reusable, this new material that we would wish to have? Now, in this circular paradigm, people often talk about that circularity will solve the issues. Globally, if we think about the metal sector, if 100% of metals are recycled, 100% recycled, it will only satisfy 50% of society's demands for material. So we need additional material. So if we just digress for a moment, if we need additional material because the demands of society are such that reuse of material is insufficient, we need to question, where is that additional material coming from? And I would suggest we want it to be responsibly sourced. Now, what do I mean by that? Responsibly sourced material, well, it's going to have large reserves because we need a lot of this to build what society needs as we try and deliver the UN Sustainable Development Goals and serve what society needs in terms of resilience, for example, and housing. It needs to be efficient in terms of land use because there are constraints on that. Once having used the land, full restoration is required. We need to support biodiversity in the process and afterwards, and we need to be looking for it to contribute towards whole life carbon. These are all the things we need for this new material, in addition to the recycled material that we obviously need to be using in circularity. Now, I would suggest, and I would suggest, and I ask you to consider that concrete can satisfy this requirement for a new material. I think it satisfies the versatility required here in terms of the properties and the range of products available. It can be a concrete block, it can be a concrete bridge beam, it can be a paving stone, it can be poured on site as a linear, a flat, a curved element. And you can have infinite mixed designs for different strengths and performance. And it meets the requirements so that the contractors can deliver this in the most efficient way. It has these properties we've already seen to give the performance, whether it's an office, whether it's retail, whether it's accommodation. And it can be demountable or long life and adaptable, fully reusable. It absorbs CO2. That's a great story we have in terms of recarbonation. Speakers that follow me, quite rightly, will be addressing the manufacture stage where we do emit CO2. And we're doing a lot of work. And it was great to hear from the Vice President of Penwa on the CCUS activity that's already underway. The cement manufacturing industry has already done a lot. We use others' wastes, which is a very circular thing to be doing, and they've been doing that for decades. So it's very resource efficient. We can utilize renewable energy, and we've got new binders coming on stream and carbon capture that we've heard of. This happens to be an example from Europe. So I would suggest that concrete can be this new material. We do need to address the CO2. So this was a former extraction of aggregates. It's now a national arboretum supporting needs of biodiversity and as an arboretum, and also place of social value. So we've got a great story to tell in terms of supporting the biodiversity needs of our planet. In terms of CO2, the global producers came together and launched in September last year a climate ambition statement, which pledges towards carbon neutral concrete. And part of that is developing a roadmap globally. So you can be assured that this isn't just an issue being addressed in your part of the world, but we've got members from all regions who are committed to this carbon neutral concrete by 2050. And one of the things they're already doing is developing innovation platforms so that globally we've pulled together a network of 40 academic institutions and 30 industrial partners. We have an Innovatively Open Challenge, which is targeting startup companies and particular technologies down here in order to accelerate those technologies, their implementation. So they're all working towards the future. But as for now, globally, there's a lot of text on this slide, but we're measuring and reporting on CO2 emissions and have for years to enable benchmarking across the industry globally. I mentioned innovation, and we're sharing good practice and promoting knowledge sharing across the industry. So the good things that are currently being done can be done more broadly and more widely. And many of the CO2 reductions that we can achieve can be achieved with known technology now, and we need to accelerate those actions. Bill, thank you very much for inviting me. Thank you.
I would like to thank our partner, Penwa, Senator Mike Cuff, and MLA Richard Gottfried, our speakers, and of course, all of you for attending today. This webinar was recorded and is available on the PNBRC website at buildingresiliencecoalition.org and the PNBRC YouTube channel. We encourage you to share this with your networks and join us again as we continue to explore the benefits of cement, concrete, and the concrete masonry's contribution to sustainability. Thank you for joining us. Good day.